Hi everyone, my name's Azza, and today we're going to go through an S level statistics question on permutation and combinations. So, this is a diagram question that many students find confusing, including me when I first saw it. So, this is basically just an upgraded question of your normal average diagram question, like this one, the taxi question. See how small it is compared to the airplane one? So this is basically just the big boss of the diagram question for permanent comps. Okay, so for question one, wait, let's read the question first. It says here a small aeroplane has 14 seats. The seats are arranged in four rows of three seats and a back row of two seats, as stated in the diagram. So for the first question, this is easy because it says it's just asking us how many possible seating arrangements are there for the 12 passengers. Give your answers to three significant figures. So the important keywords here are arrangements, as it shows us this is gonna be about permutations, and give your answers to three significant figures. Make sure it's three. Okay, so for this question, there are 12 passengers and there are 14 seats. So from 14 seats, we must arrange 12 passengers, which is equal to 4.36 times 10 to the power of 10. Okay, this is easy. Now we're going to the question 2, the harder one. These 12 passengers consist of two married couples, Mr. and Mrs. Lin and Mr. and Mrs. Brown. Four people already. Five students and three business people. 12 people we have to arrange in an airplane. Okay, so it says here the three business people sit in the front row. There are only three front rows, so this is obviously 3p3. Okay, and then the five students each sit at a window seat. Okay, so this is where most students make their mistakes, including me. Okay, then the five students each sit at a window seat. So this is where most students make their mistakes, including me. So there are currently how many window seats? One, two, three, four, five, six, seven. Okay, so there are seven window seats. There are five students. Most students just do 7p5. Without further reading, what does the next question says? The next question says, the next sentence says, Mr. and Mrs. Lin sit in the same row on the same side of the aisle. Mr. and Mrs. Brown sit in another row on the same side of the aisle. So that which means those two married couples must be in this area, occupying two window seats. So the trick to do this question is to do the married couples first. We'll do the students later. We'll come back to them later. Okay, so Mr. and Mrs. Lin sit in the same row on the same side of the aisle. As the same side of the aisle. Mr. and Mrs. Brown sit in another row on the same side of the aisle. So this is just means they sit here and they must be together. So we must arrange them. We must arrange the two married couples. So there are one, two, three choices here. So it's three, and there are two married couples. So two, 3p2. But you have to also times it with 2 factorial. You know why? Because on the left, it could be on the left seat here, it could be Mr. Lin or Mrs. Lin. So it doesn't say if Mr. Lin is on the left or on the right, so 2 factorial. And this also same goes for the Mr. and Mrs. Brown, so times another 2 factorial. And then after that we can finally do the students. After the married couple takes 2 seats, I mean 4 seats in total, but it's 2 window seats. There are only 1, 2, 3, 4, 5 window seats left for the students. Just perfect. So 5p5. And this is equivalent to 17280, which is, you round it off to 17300. Okay, as a summary, 3p3, remember, is for the 3 business people at the front, and then this whole thing is for the married couples, and this is for the students. Okay, now moving on to question 3. If instead the 12 passengers are seated randomly, find the probability that Mrs. Lin sits directly behind a student and Mrs. Brown sit in the front row. So, okay, let's do this. So, let's do Mrs. Brown sit in the front row first because it's the easiest and the most logical way to do this. So, there are only 3 front rows. So, we could do 3p1 times Mrs. Lin can only sit directly behind a student in only 10 seats. Okay, let's say Mrs. Brown, since she sits on the front row, let's say she took the middle row. Now, what's left for the possible arrangement for Mrs. Lin is either the student sits. Okay, maybe I should use a clearer one. Either the student sits here, and then Mrs. Lin sits here, and then, or the student sits here, and Mrs. Lin has to sit here, or here, or the student can also sit here, and Lin here, and then the students can only sit here, and Lin here. You know why the student cannot sit here? It's because there's no back seat for Mrs. Lin to sit on. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, wait, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know why. I'm sorry. I don't know why I put Mrs. Lin here. It cannot be possible Mrs. Lin sit here because Mrs. Brown is already in front. So there's 10 possible way for Mrs. Lin to sit directly behind a student. So it's 10 P1. And then there are 5 students. So that it is 5P1. And if you're asking if do we also arrange the students, which is all equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, we don't, because we consider Mrs. Lin and the student together, because wherever the student sits, Mrs. Lin has to be at the back. The student sits here, Mrs. Lin is here. student sits here, Mrs. Lin sits over here. So we consider them as one. And then there are 9 people left, and there are, so we use 3 seats already, so there are 11 seats left. So from these 11 seats, we can put the 9 there. Okay. As a summary, this is Mrs. Brown, uh, Mrs. Lin behind student, and this is the 9 people left, the background characters. Okay, so the answer is 29937600000. Oh yeah, only 4 zeros. But this is not the answer, because note that it says probability. So the probability is equal to our answer here divided by no restrictions, like they can sit anywhere, which is our first one here, 14p12, which is 4.36 times 10 to the power of 10, to the power of 10. So this is gonna be equal to 0.0687. Boom. So I don't know about you guys, but this is one of the questions that was known as notorious in my batch, because my batch found it hard. So I hope this helps, and thank you for watching.